Hey everybody, so this video is going to be about how to reverse code in uh, Excel. Sorry, I don't know why I was blanking on that word. So one of the very first things you have to do, so let me go ahead and share my screen. One of the very first things you have to do is identify what your highest value is. Now sometimes you'll know this just off the bat because you'll know what the highest possible value in your scale was. So if you gave them if you had participants respond on a scale from 1 to 7, you know that the highest value is 7. But if you don't know, then you can use Excel to figure that out fairly easily. So what we're going to do is we're going to use a simple formula called max. So I'm going to start typing max. You see it there. And I'm going to pull up. All right. And then I'm just going to close the parentheses so you can see the completed formula there. I'm just going to press enter. And there we go. That's 7. So we know that that's the max number. Now, I know that that is correct because I made the scale. So I know it's 7. And honestly, the best way to know is to look at your scale. All right, if your scale only goes from 1 to 7, then you know that your max value is 7. And the reason I say that's the best way is because, although it wasn't the case here, it is possible that you have participants never use the highest possible value. I've never personally experienced, I've never personally experienced that, but it is possible. I have experienced situations where none of my participants use the lowest possible value. So it is possible for the highest possible value on your scale to not appear in your data. So it's always best to figure out what your highest value is from your scale. So you go back to your survey or you go back to your research materials and you look at what scale you gave participants. If you gave them a scale from 1 to 7, then you know that the highest value is 7. Now, the reason you need to know that the highest value is 7, or what the highest value is because in order to reverse code, you have to subtract each participant's response from a number that is one value equal, one value higher than the highest possible response. So in the case of the example here, the highest possible example or the highest possible response was a 7, and so we would subtract every participant's response from 8, which is one value higher than the highest possible response. Now what does this do? Well, remember what reverse coding is when you take high numbers and flip it. So let's say high numbers mean, let's say you gave participants a question where you asked them to what extent do they agree with the statement that they are ambitious. 7 meaning extremely, 1 meaning not at all. All right. Well, for whatever reason, if you wanted, so on that original scale, higher numbers mean I agree that I am ambitious. Lower numbers mean that I do not agree that I am ambitious. Well, let's imagine that for some reason you need to reverse code this, and you see this a lot when you have scales like the Rosenberg self-esteem scale. Anytime you have a scale, many times you'll have items on that scale. So a measure that has like the Rosenberg self-esteem scale has 10 items, and several, I forget how many, but several of those items on that scale need to be reverse coded because in general, you want all the numbers on each item to line up. And the reason you want them to line, and by line up, I mean that higher numbers on every item would indicate, in terms of the Rosenberg self-esteem scale, you want you want high numbers on all items to indicate greater self-esteem, and high numbers or low numbers on all items to indicate less self-esteem. The reason you want that is so that you can combine or aggregate the items to create an index of self-esteem. So you don't use every item of self-esteem to represent their self-esteem. You create an aggregate of those 10 items to represent self-esteem. So you're going to have to reverse code several of those items before you aggregate them. And so to reverse code, again, you would take equals one value higher than the highest possible and minus it. Well, why? Well, let's take, for example, this scale. The highest value is a 7. So let's say somebody gave us a 7. Well, let's say somebody else gave us a 1. So we have the highest possible score and the lowest possible score. Well, we're going to subtract each of them from 8. So again, we want to reverse score this. So we want that 7 to be a 1, and we want that 1 to be a 7. Well, all we have to do is subtract them both from 8. And ta-da! The person who had a 7 is now a 1, and the person who had a 1 is now a 7. So it's reverse coded. All right, so that's essentially what we're going to do to every participant. So we're going to use a column title here that tells us that it's reverse coded. So the original is PC3, so we're going to use PC3R. So that tells us it's reverse coded. And then we just equals 8, because that's one value higher than the highest possible value of the scale, minus the participant's response. And that's it. Enter. All right. And there we go. Now, all you have to do is pull that down all the way and press it. All right. Your data is copied. Now, you always want to make sure that you're not missing any data, like that. All right. So that person was missing data. Well, let's see what happened. And this is part of the reason you need to check. Now you got a score that it isn't impossible, because you've minus, essentially, Excel treats that as a 0. So you've essentially subtracted 0 from 8, which is 8. All right, so now you've got a score in your resulting data that isn't possible. All right, so that's another issue to deal with. So that's why you want to spot check your data to make sure you're not missing any values and deal with those missing values. But again, the reverse coding is very simple. You just identify one value above the highest possible value of the scale. This scale used a 1 for 1. This item used a 1 to 7 Likert scale. So one value higher than the highest possible is 8. So 8 minus the participant's answer gives us our reverse coding. So 5 is equivalent to 3. 4 is the midpoint. 6 is equivalent to 2. 7 is equivalent to 1. That's so the scale is reverse coded. And that is how you reverse code. All right, guys, that's it for this video. As always, if you have any questions, let me know. Otherwise, take it easy.